A very good afternoon, class. So last time we started with probability distribution of Maths 2 section, and we are solving exercise 8.2, the topic related to probability distribution of continuous random variable. And last time we saw how to calculate the values related to PDF, probability distribution functions of a continuous random variable X. Now today class, the three sums which we'll be doing of the exercise, that is sum number 8, 9 and 10, is dealing how to find out the CDF, the cumulative distribution function of a continuous random variable, which is also represented by f of x, that is capital F of x. So just have a look class how to solve the sums related to CDF. So we are starting with sum number 8. Following is the PDF of a continuous random variable x. F of x is given as x upon 8, condition given is 0, less than x, less than 4, 0 otherwise. Find the expression for the CDF of x and then find the values of f of x at x is equal to 0.5, 1.7 and 5. So let's have a look how to solve such kind of a sum class. Now over here, I guess the sum is modified class. Instead of 5, there's a printing mistake. This is not 5 over here. In place of 5, keep in mind you have to write the value 4 over here. So instead of 5, make it 4 because they are talking about the values given between 0 less than x less than 4. Alright, so just make a careful attention over this. Instead of 5, you have to make it 4. Okay, so there's a printing mistake in the question. So that correction I've done over here, as you can see. So f of x is a PDF of a continuous random variable x which is given. So in order to find the expression for CDF of x, we will assume the first line as, let capital F of x be the CDF of x. So I hope you all are clear with this particular line. Now the formula for CDF is nothing but this. F of x is equal to probability x less than equal to x. The formula is integration minus infinity to x. F of x with respect to dx. So f of x stands for the CDF function which we are going to calculate. So I repeat the formula again class. For f of x, probability x less than equal to x, integration minus infinity to x, f of x the whole x dx. So when we split up the formula, it becomes like this: integration minus infinity to 0, f of x with respect to dx, plus 0 to x, f of x dx. Now minus infinity to 0 is nothing but 0, plus integration 0 to x, f of x with respect to dx. So f of x given over here is nothing but x upon 8 as it is given in the question. So integration 0 to x, x upon 8 dx. So on integrating 1 upon 8, I'll remove outside as it is a constant. Integration of x square, integration of x is nothing but x square upon 2. So the integrals gets transferred on the right hand side, 0 to x. So x square upon 16, 0 to x. So the expression of finding out f of x becomes like this. F of x is equal to x square upon 16 for 0 less than x less than 4. Now easily we can find out the value of f of x. So the first one which was asked was x is equal to 0.5. So instead of x, we'll substitute 0.5 the whole square upon 16, which gives 0.25 upon 16. On removing the decimal, 25 upon 16 into 100, 25 ones are 25 fours are, answer is 1 upon 64. In the similar manner, f of x at x is equal to minus x is equal to 1.7, sorry. So f of 1.7 is equal to 1.7 the whole square upon 16, which gives 2.89 upon 16. Then f of x at x is equal to 4, as we had changed the question. There was a printing mistake. So f of 4 is 4 square by 16. 16 by 16, answer is 1. So I hope you all are clear with sum number 8. So class, for this you have to remember the formula which I taught you all just now. So we'll be revising the formula in our next two sums as well. So pay attention. The PDF of a continuous random variable x is f of x 3x square by 8, and the condition put is 0 less than x less than 2. Also 0 otherwise. You have to determine the CDF of x and hence find out the value of probability x less than 1, probability x less than minus 2, probability x greater than 0, and 1 less than x less than 2. So let's have a look how to start. Again given for a PDF, so we'll assume let f of x be the CDF of x. So again, I'll put the formula. Capital F of x is equal to probability x less than equal to x minus infinity to x integration f of x the whole of x dx. On breaking up the formula, I get integration minus infinity to 0 f of x the whole x dx plus integration 0 to x f of x the whole x dx. So minus infinity to 0 always gives 0 plus integration 0 to x, substitute the question, which is 3x square by 8 dx. Now 3 upon 8 is constant, so I'll remove it outside, and integration of x square is nothing but x cube upon 3. So once the integration is done, I transfer the integrals to the right hand side from 0 to x. So on multiplying, I get 3x cube upon 24, 0 to x, which is nothing but 3 ones are 3 8s are 24. So x cube upon 8, 0 to x. So the CDF expression becomes f of x is equal to x cube upon 8, 0 less than x less than 2. So now as we are ready with our CDF function, we can find all the probabilities which is asked. So starting with probability of x less than 1. So f of 1 is equal to 1 cube upon 8, answer is 1 by 8. Coming to the next one, probability of x less than minus 2. Now if you all paid attention class, the condition put forward was 0 less than x less than 2. So iska matlab the numbers which come between 0 to 2 is nothing but 0, 1 and 2. So there is no scope for negative numbers over here. So f of minus 2 in case as you see is 0. It does not exist because it doesn't fit in this particular condition. Probability of x greater than 0. Probability of x greater than 0 is nothing but f of 2 minus f of 0, because the condition put forward is from 0 up till 2. So greater than 0 is nothing but it will be less than 2, in between 2 to 0. So f of 2 minus f of 0, that is 2 cube upon 8 plus 0 cube upon 8, which is 0. So 2 cube upon 8 is 8 upon 8, answer is 1. 1 less than x less than 2 is nothing but f of 2 minus f of 1. So 2 cube upon 8, which is 1, just now we saw, and 1 cube upon 8 is 1 upon 8. So 1 minus 1 upon 8, answer is 7 upon 8. So I hope you all are clear with sum number 9 as well. Coming towards sum number 10. If a random variable x has PDF, f of x is equal to c upon x, and the condition put forward is 1 less than x less than 3 and 0 otherwise. Also c is greater than 0. You have to find 4 things over here. First, you have to find out the value of small c in the question. Then you have to find out e of x, that is mean of x or expected value of x, variance of x, and finally f of x, that is the CDF. So these are the 4 things which they have asked us to find out. So let's see how it is done. So given PDF of a random variable x, the question is given. Now for a PDF of x, what is the formula class? Remember, minus infinity to infinity f of x dx is equal to 1. So this was the formula which I taught you all in the last lectures when we were doing PDF. So as the condition put forth is integral 1 to 3 c upon x dx is equal to 1. So as c is a constant, we take it outside, and integration of x is nothing but log x. So once we have integrated, so the integrals move on the right hand side, it becomes c into log x 1 to 3 is equal to 1. So as per rule, we first put the upper limit and then subtract the lower limit like this. So c bracket open log 3 minus log 1 is equal to 1. Now value of log 1 is nothing but 0. So log 3 minus 0 gives you log 3. So c log 3 is equal to 1. C ka value you get it as 1 upon log 3. So with this, out of the 4, we have found out the value of the first one, that is c. Now they are telling us to find out e of x and v of x. So let's see. Okay, just a second class. By mistake, the page changed. Okay. So over here, just give me a second class. Some technical difficulties arise. All right. Okay. So as I told you, the value of c is 1 upon log 3. We found out the first value. Now they have told us to find out e of x and v of x. That is expected value of x and variance of x. Now, if you all remember class, I already explained you all how to find out expected value by using the tables we used to find out. We have already done this in exercise 8.1. So, e of x is equal to integration 1 to 3 x into f of x dx. That's the formula of e of x. So, what's the formula of e of x? X multiplied by f of x. So, e of x is equal to integration 1 to 3 x into, remember class, we just now found out the value of c and it was c upon x. And the value of c which we got was 1 upon log 3. So 1 upon log 3 into x will become 1 upon x log 3. So got it? In place of f of x, how did I put 1 upon x log 3? Alright, so c ka value just now we found out, it is 1 upon log 3 divided by x. So divide will change into multiplication and x will become 1 upon x. So x gets cancelled. So you're left with integration 1 to 3, 1 upon log 3 dx. Okay. So 1 upon log 3 is the constant. So we'll remove 1 upon log 3 outside the integration sign. So we are left with 1 inside. Integration of 1 is nothing but x. So the integrals gets transferred on the right hand side, 1 to 3. So 1 upon log 3, 3 minus 1, which is nothing but 2 log 3. So we have found out the second value as well, that is e of x. Now moving forward to variance of x, the variance ka formula was, remember class, ex square minus ex the whole square. So total of ex square minus total of ex the whole square. So ex square will be nothing but integration minus infinity to infinity x square into f of x dx minus integration minus infinity to infinity x into f of x dx the whole square. Now remember class, this just now we found out the value of e of x. Hai na? So e of x ka value we will directly substitute and we can square it. But integration of x square f of x we'll be finding out just now. So integration 1 to 3 x square into 1 upon x log 3 dx. So ek x cut ho jayega. So you are left with integration 1 to 3 x upon log 3 dx. Similarly, you are subtracting 2 upon log 3 which you found out just now. We are taking uska the whole square. As the formula states, it is the whole square. So 2 ka square is nothing but 4 and log 3 the whole square we'll keep it as it is. So again we'll take out 1 upon 3 constant and integration of x is nothing but x square upon 2. So the integrals gets transferred to the right hand side 1 to 3 minus 4 upon log 3 the whole square. So now first we'll put the upper limit and then subtract the lower limit. So we get 1 upon log 3 bracket open 3 square upon 2 minus 1 square upon 2 minus 4 upon log 3 the whole square. So 3 square is nothing but 9, 1 square is 1. So 9 minus 1 upon 2 gives you log 1 upon log 3, 8 upon 2 minus 4 upon log 3 the whole square. So 2 ones are 2 fours are 8 gets cancelled. So you're left with 4 upon log 3 minus 4 upon log 3 the whole square. So I'll remove 4 common outside. So as you can see, what is left inside is 1 upon log 3 minus 1 upon log 3 the whole square. Now the denominators are not same. So we'll first make the denominators same by multiplying one more log 3 with the denominator, because अपने को common denominator क्या लाना है, log 3 the whole square. And what you're multiplying in the denominator will be multiplied in the numerator like this. So you are multiplying 1 को by log 3, and at the same time you're multiplying log 3 with one more log 3. So the final answer left is log 3 minus 1 upon log 3 the whole square. So your final answer of V of x is 4 into log 3 minus 1 upon log 3 the whole square. So with this we have found out the third part as well. Now they are telling us to find out capital F of x, that is CDF. So capital F of x is a PDF. So the CDF given will be integration 0 to x 1 upon x log 3 dx. So 1 upon log 3 I'll remove outside, and integration of 1 upon x is nothing but log x. So your F of x ka answer is log x upon log 3, and the integrals gets transferred like this to the right hand side. So this is F of x is equal to log mod of x upon log 3. So with this, we finish off with exercise 8.2 and the sums related to PDF and CDF of a continuous random variable. So I hope you'll have followed the sums and keep practicing them in the notebook. If you have not followed, please go through the formula and listen to the video once again. Still, if the doubt persists, please let me know in the comment section. So I stop here for today class. In the next lecture, I'll be completing off with the lesson, as we'll be finishing off with the miscellaneous sums related to continuous random variable K type. And with that, finally, our probability distribution will get over with it. So thank you so much class for listening to me. I stop here for today. Take care, keep practicing and keep studying, and have a very safe Diwali as well. All right. So happy Diwali in advance class, and I hope you all take care and don't become careless as far as your health is concerned. Okay. So thank you so much class. I stop here for today.